Okay, so I'm going to go back and finish this last problem. So again, the issue is the student is viewing the 7, but they're viewing the number behind it as counting. So like 1, 2, 3, 4, 5, 6, 7, 8, 9. So of course 10 comes next. And that's not true because if you're going up by 0.1s, 8 is going to come next. And again, remember if I cover up that 0, that's 7.1. That's not the same as what goes over here, which is 8. So again, we talked about how you could have the tick marks be whole numbers, not put the 0.0 there, and just have it so that these are one place value smaller. But again, that might not make sense to a kid. So there's some other options we can do. All right, one is if we had paper strips, and I'm going to make this a little bit smaller. So say I have, where's my ruler at? Okay, I'm going to make, let's see, what do I have? I don't want to do 7, but say that I'm going to let my centimeters be 1, okay? So that would be, this would be 7. Okay, so there's 1. So each of these now are my wholes. So this is 1, 1, 1, 1, 1. So I'm going to use paper strips. So there's 7. And then if I keep adding, these are my millimeters. So I would have, 0.1 and 0.2 and 0.3 and 0.4, 0.5 and 0.6, 0.7, 0.8, and 0.9. So then a kid could see if I add another 0.1, that equals, and again, I could maybe put another, if I had paper strips, I could put a paper strip underneath it so they really believe me. But if I add that extra 0.1 or that extra tenth, they can hopefully see that then suddenly they make a whole again. So I can kind of use a length model, a linear model to help them. So I can have them build the 7.9. And again, with paper strips, and then I could have them add that extra 0.1 and then suddenly realize that now it equals 8, okay? And I might need 2 paper strips to really help them believe me, but that's an option. Another option is to maybe do base 10 blocks. And so I'm gonna let my little guy be tenths and my longs, to be my whole, okay? So 7.9, so I could count with my child. So I have 1, 2, 3, 4, 5, 6, 7. Okay, there's my 7. And I'm right here. And then let's talk about what these decimals are. So I have 7.1, 7.2, 7.3, 7.4, 7.5, then 7.6, 7.7, 7.8, 7.9. So I'm right there. And so then I could add another base 10 block, okay, a single, and then I can talk to the student about, in base 10, do we ever have 10 singles? And the answer is no, we never ever have 10 singles. We would regroup these into another long. Oopsie. And so after we hit 7.9, when we get 10 singles, we would have to regroup because in base 10 you can never have 10. So we would regroup these guys. And when we regroup, then we would have 8 longs, which is the number 8. If I have 8 longs, I would be at 8. So I can kind of use the structure of a number line to help them, but I don't know that that's the best strategy. I think using a strip diagram with to scale paper strips, that they can see that when they build it, they get equal to an 8. I think that's going to be helpful. I do also think that covering up that 0 and pointing out that 7.1 is down here on their number line. So that the other thing that helps kids sometimes is money. So if you think of this as 7.9, like $7.90, and this is $7.10, that cannot be to the right of it. That's not logical. So then trying to build on that, like, oh yeah, that couldn't be possible. And then maybe use these other strategies to help. All right, hopefully that helps on those. Go ahead and try the other ones for me to grade. And again, these are more like test questions. So I just really want to make sure you know what you're doing and that you feel confident in it. All right, have a great day. I will talk to you soon.